Hi there and welcome to our next video on some exam questions to do with atomic structure. Our first exam question states, the diagram represents three atoms K, L and M. Which two of the atoms are isotopes of the same element? Again, we're given a key this time. We have protons, neutrons and electrons. Remember, isotopes contain a different number of neutrons but the same number of protons. Okay, so if we have a look now, K and L contain the same number of protons, the same number of electrons, but different number of neutrons. So the isotopes are going to be K and L. That would get you 1 mark. Give a reason why the two atoms that you chose in part AI are atoms of the same element. Well, they are atoms of the same element because they have the same proton number, so the same atomic number. So they have the same atomic number. That will get you 1 mark. Different isotopes of the same element, and the reason for that is because that they have a different number of neutrons or different mass number. So they have a different number of neutrons or a different mass number. Okay, and that will get you 2 marks. 1 for that, 1 for this. Okay. The table below gives some information about the radioactive isotope thorium-230. The mass number is 230 and the atomic number is 90. So we could just write that as Th230 90. Okay, how many electrons are there in one atom of thorium-230? Well, atomic number 90 for 1 mark. How many neutrons? Well, that's going to be 230 subtract 90, 0, 4, 1. So that's going to be 140. So 140 neutrons. And that will also give you another mark. Next question now. When a thorium-230 nucleus decays, it emits radiation and changes it into radium-226. What type of radiation, alpha, beta or gamma, is emitted by thorium-230? And you need to give a reason for your answer. Okay, and this whole question is worth 3 marks. So if you have a look now, the atomic number has decreased by 2 and the mass number has decreased by 4. So it's going to be alpha decay. And the reason is so that we know that the atomic number has decreased by 2 and the mass number has decreased by 4. Okay, and why is it because of this? Is because it's the same as a helium nucleus. So same as a helium nucleus. So you would have your alpha here, 4 at the top, 2 at the bottom, and if you're subtracting it, the mass number would be subtracted by 4 and the bottom number would be subtracted by 2, the atomic number, and that will get you 3 marks. Next question. Some street lamps contain sodium. Below are 2 isotopes of sodium. What are isotopes? Simple 2-mark question. Isotopes have the same number of protons but a different number of neutrons. Or you could have said they have the same atomic number but they have a different mass number. Okay, that will get you 2 marks. Next question. How many protons and neutrons are in the nucleus of sodium? So the number of protons is the bottom number, 11. The number of neutrons is going to be 23. Subtract 11, which is going to be 12. So 12 neutrons for 2 marks. The sodium atoms emit light. What would cause light to be emitted from a sodium atom? Tick one box. So electrons being emitted from the nucleus, electrons falling to a lower energy level, electrons leaving the atom when it's ionized, or electrons moving to a higher energy level. So remember, when the electrons absorb energy, absorb light, they move to a higher energy level away from the nucleus. But when they emit that light, then they move back closer to the nucleus in their original electron shell. So when they emit the light, they fall to a lower energy level, and that will get you 1 mark. Okay, next question. Alpha, beta, and gamma are types of nuclear radiation. A teacher sets up a demonstration of the penetration properties of alpha, beta, and gamma radiation. The figure below shows the demonstration. Complete the figure above by writing the name of the radiation in each box, and it's worth 2 marks. So paper, that's going to be alpha. 5 centimeters of aluminium is going to be beta, and 5 centimeters of lead is going to be gamma. Okay, and that will get you 2 marks. Give 2 safety precautions the teacher should take in the demonstration. So you could have said wear goggles, and you could have said wear gloves. You could have also said keep a safe distance away. So keep a safe distance away. Okay, and that will get you 2 marks. Next question. The equation below shows the process by which 2 atomic nuclei join to form a different nucleus. Where does the process shown by the equation above naturally happen? So tick one box: inside the earth, inside a nuclear power station, or inside the sun. Now the key thing is naturally. So it can't be inside a nuclear power station, inside the earth, or inside the sun. Now it's hydrogen producing helium, and that can happen on the sun. Okay, 1 mark. Next question. Use the correct answer from the box to complete the sentence. The process of joining 2 atomic nuclei to form a different nucleus is called nuclear fusion. Remember, fission is when you're separating a large unstable nucleus, and fusion is when you're joining 2 nuclei together. So fusion will get you 1 mark. What is released during this process? Drawing around the correct answer. Remember, in fusion, some of the mass is converted into energy, and that will get you another mark. Next question. The names of 3 types of radiation are given in list A. Some properties of these 3 types of radiation are given in list B. Draw 1 line from each type of radiation in list A to its correct property in list B. So alpha, which one is it? Is it will pass through paper but is stopped by thin metal, has the shortest range in air, will not harm human cell, and it's very weakly ionizing. So alpha has the shortest range in air. It will pass through paper. It won't pass through paper, so it can't be the first one. Beta is will pass through paper, but then is stopped by thin metal. And finally, gamma is very weakly ionizing. It's very penetrating, but it's very weakly ionizing, and that will get you 3 marks. Okay, next question. The radioactive isotope iodine 123 can be used by a doctor to examine the thyroid gland of a patient. The iodine taken as a tablet is absorbed by the thyroid gland. The gamma radiation emitted as the iodine atom decays is detected outside the body. Now, the doctor uses the isotope emitting gamma radiation to examine the thyroid gland rather than an isotope emitting alpha or beta radiation? Which one of the following gives a reason why gamma radiation is used? Take one box. So gamma radiation will pass through the body. Gamma radiation is not deflected by a magnet, or gamma radiation has the long range in air. So related to the question, it could have been that, but it's not related to the question. It will pass through the body for 1 mark. Next question. Iodine 123 has a half-life of 13 hours. Use a word from the box to complete the sentence. After 13 hours, something of the iodine 123 atoms the thyroid absorbed have decayed. So after 13 hours is going to be half. Remember, that's what a half-life is the time taken for half of it to decay. That will get you 1 mark. Iodine 123 and iodine 131 are two isotopes of iodine. Draw a ring around the correct answer to complete the sentence. The nucleus of an iodine 123 atom has the same number of what as the nucleus of the iodine 131 atom. Remember, isotopes have the same number of protons but a different number of neutrons. So the correct answer to this is that they have the same number of protons but a different number of neutrons. That will get you 1 mark. And that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.